This video goes over Chapter 5 homework, problems 5, 11, 13, 22, and 26A. Problem 11, they give you the payout when you drill for oil. You can either lose money 25% of the time, make a little bit of money 70% of the time, make a lot of money 5% of the time. They want you to be able to calculate the expected value and the variance or standard deviation. They also wanted to plot it. So if I take these two, that's the payouts and the probabilities, grab it and build this column chart like that, then I got to edit this. I go under Design, select Data, and get rid of the X, and then change where your X values are these. That's what we want. So that's the graph. To calculate the expected value, I have to create a column that is X times the probability of X. Copy that down. And then my expected value, expected profit, which is also my mean, which is also my average. It's just the sum of these three numbers. To calculate the variance and standard deviation, I start with the difference between this and the mean. I got to square it, and then that gets multiplied by the probability. I'm going to copy this down, so I'm going to put some dollar signs around my mean. Copy this down. My variance is the sum of these numbers. My standard deviation is the square root of my variance. You know one, you know the other. Problem 13, they want you to calculate the payout. What you do is that insurance companies take a premium, people pay them a premium, so every time period the insurance company gets $400. There's a chance that this jewelry can be stolen, and that happens, not likely, but there's a likelihood of that. And if that happens, they got to pay out $50,000. So the two payouts are they either get $400 or they lose $49,600. The reason it's $49,600, it's they get this, but they got to pay out this, so it's negative. So this happens a lot of times. This doesn't happen very often. So from that, what is the well, that's part A. The next one, they want you to calculate the expected value. So the same thing as before, we need to calculate P times the probability that X equals X. And we take the product, this times this. Copy that down. And then if I add those up, so my expected value, expected profit, or the mean, or the average, they're all the same thing. What that's equal to is summing those up. Let me do it this way. Let me do it like this. These two numbers. So there you go. So this insurance company will be profitable because if they do this enough times, every time period they expect to make at least $150. Or not at least, expect to make $150. The last part of the question is, what should the premium be? What should this be so that this number, what should this be so that the expected profit is $1,000? So I'm just going to play with this number, which is this one. That's this one. Yeah. So let's make that. What if I change the premium to $1,000? The expected profit is $750. What if I make this $1,100? $850. What if I make it $1,250? There you go. So if I make the premium $1,200, if I charge $1,200 every time period, my expected profit is that. Okay, 522. We have people who walk in and they either buy something or they don't. The chances that they're going to buy something over the long-term period is 30%. So if I look at 6 people walk in, what are the chances that they're going to buy something? So the binomial distribution of all the possible outcomes is 6 people walk in, None of them can buy something. One of them can buy something. Two of them buy something. Three of them buy something. Four of them buy something. All the way up to all of them buy something. The chances that it occurs, I'm going to use the binom dist formula. And then the binom dist, and your first argument is the outcome. The second argument is the number of trials, 6. The probability of success of one trial is 30%. And then 0 to come up with exactly the probability that exactly 0 people are going to buy something. So the probability that exactly 0 people out of the next 6 are going to buy something is 0.118. The chances that exactly one person is going to buy something is 0.303. The chances that exactly 2 people is 0.324. All the way up until the chances that everybody is going to buy something, that the number of people who buy something is exactly 6, is that number. The total of that sums to 1. The cumulative, so this is the cumulative distribution, which I don't think it asks you to do. But let's go ahead and do it. The cumulative is the exact same formula. It's the exact same formula as that over there, except the last argument here is 0, and here it's 1. And what this gives you is the chances of that or less. So the chances that 0 or less people is the same number. That's not a mystery. You can't have negative people. But look at the next one. The chances that 1 or less people buy something. This number is different than this one, but they're related. This number is these two added up. If I add these two numbers up, that's what I get. How I can get there quickly is the binom dist and use an argument of 1 instead of 0. The chances that 2 or less, which is the sum of these, is what this number is. I didn't have to sum them up. I could, but this number is the same thing. So the chances that 6 or less people are going to buy something out of 6 people walking in, that's every possibility. It's 100%. So this is what they want you to solve. This is how I solved them, and this is another way to solve them. The first one is the chances of exactly 5 people. Well, that's what this number is. So I just grabbed it. Chances of 3 or more. Chances that are 3 or more. So 3 or more of these. So it's these. 2 or it's 1 minus this. Is either add these up or 1 minus this, and that's how I did it. I did it by 1 minus the cumulative of 2 or less. The chances at 3 or more is what this is equal to. It's equal to 1 minus the probability that x is less than or equal to 2. And so that's less than or equal to 2 there, so 1 minus that gives me that number. That's how I did it. You could do it another way. You could just sum 3 and more. Look at the same answer. Less than or equal to 2, I just solved for it. It's this number. Or I could sum these 3. That's less than or equal to 2, 0, 1, or 2. Either one gives the same number. Greater than or equal to 1 is 1 minus the probability. So this one, I did 1 minus the probability that x is less than or equal to 0. Or equal to 0. The same thing. 1 minus probability that x is less than or equal to 0 or equal to 0. Looks like I did the less than or equal to 0, the first one. Or I could just add up 1 or bigger, which is these numbers. It's the same thing. That's 22. And then 26, they want you to calculate. They want to know what is the probability that you'll be between the mean plus or minus standard deviation. It's 95%. This is just the empirical rule. Plus or minus 1 is 68, plus or minus 2, 95, plus or minus 3 is 99.73%. Then they want you to calculate the mean. When you're talking about a binomial distribution, you don't have to use these formulas. You could do it this way to get these numbers. It would work, but there's a shortcut when it's binomial, and the shortcut is that the mean is just n times p. N times p. And the variance is n times p times 1 minus p. N times p times 1 minus p. Standard deviation always the square root of the variance. Once we have this number, I want to calculate what the boundaries are, plus or the mean plus or minus 2 standard deviations. The mean is 1.8. The standard deviation is 1.12. So this is equal to the mean minus, this is equal to the mean minus 2 of these. Now you come up with the negative number. Well, you're never going to get a negative number. So if you wanted to make that be 0, that's fine. But I'm not. I'm going to leave it just like that. And the upper is the mean plus 2 of these. The mean plus 2 of these to come up with that. So 95% of the time, the number of purchases is going to be between this number and this one. Or between 0 and this one if you want to do it that way. Which is fine with me. Okay, that's the homework solutions. Thanks.